Hey guys, so today we're taking the GCF that we learned yesterday, and I'm going to add in some variables and exponents. So we're going to start taking the GCF of monomials instead of just regular old numbers. So quick review from yesterday. Greatest, we're talking about the largest, so the biggest. And then common, it has to be shared between both things, so both numbers, both monomials, whatever it is, it has to be shared between the two of them. And then factor is really the divisor. We're looking for something that could be divided into both things. So when we're talking about greatest common factor, we are actually finding the largest shared divisor. So when finding the GCF of coefficients, so coefficients, we're looking at the numbers, you're going to look for the largest factor. So that's what we did yesterday with tree diagrams, or some of you just listed different factors. You're looking for that biggest number. Now, when you're looking at the GCF of variables, you're going to look for the smallest exponent. So I'll kind of explain that here in a second. Let's do a couple examples with just the numbers to kind of make sure we're all still on the same page. So if we look at 12 and 16, you're looking for the biggest thing you can take out of both of them. And some of you like trees, some of you like just listing factors. So if I were to do the tree diagram, I'm going to break down this to 3 and 4. 3 is prime, so I'm done. 4 can be broken down into 2 and 2, so 4 is done. Then I can do 16, 4 times 4, 2 times 2, 2 times 2. Those go away. So then when I go to find my GCF, I can only take things out that are shared between both of them. So I'm going to take 1, 2 out of both. So that's only 1, 2 I took out. So a couple people were trying to like take 2 and say like that was that. That's not what I did. I only took 1, 2 out of both of them. Now I'm taking another 2. So there's 1, there's 1. I'm going to take another 2. And notice I can't take anything else out, so that's where I am, because this only has 3 left and there's no 3 on the green side. And then there's a couple 2's left over here on the green side, but there's no 2's left on the red side. So 2 times 2 is 4. So the GCF would be 4. Again, if you were to like list factors of it, we could take it and say 18. I've got 1 times 18, 2 times 9, 3 times 6, 4, no, 5, no, and I'm back at 6, so I know I'm done. Then I would do 42, so I have 1 times 42, 2 times 21, 3 times 14, no 4, no 5, 6 times 7, and I'm back at 7, so I know I'm done. So if I'm looking at shared, I've got to make sure they're in both of these things. So it has to be in red and blue to be shared. So those are the only 3 numbers that are shared, 1, 2, and 6. So 6 is the biggest one in between 18 and 42. So 6 would be our GCF. So those are our 2 ways we kind of learned how to do it yesterday. Again, if we were to do 21 and 18, I could break 21 down to 3 and 7. And those are both prime, so I'm already done with that one. Then I could break 84 down. I know it's divisible by 2 because it's even, so 2 and 42. Then 42 I can break down to 2 and 21. So I'm done with 42. Then 21 again, we just did that one, is 3 and 7. So then when I go to pull things out, I can pull out a 3 from both of them. And I can also pull out a 7 from both of them. So the largest shared divisor would be 21. And again, like I said yesterday, I would make sure I would look at that smallest number, and if that number can be divided into the bigger number, you know that's your greatest common factor, because the smallest number is actually going to be your greatest factor, because that's the biggest factor for the smallest number. So if you just look and see if 21 would fit in 84 first, then you would have it. Okay, next one, 16 and 60. This one I guess I'll do the other way in case other people like it. 1 times 16, 2 and 8, no 3, 4 and 4, and I know I'm done because I'm back at 4. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and 6 and 10. So again, I have to go through and look, okay, both 1s, both 2s, both 4s. I don't know what happened to that other 4 over here. I think that's it. So again, our greatest one out of 1, 2, and 4 is 4. So 4 would be the greatest common factor. So again, that was all review from yesterday. Let's look at number next, which is now I've got x squared and x to the 5th, so no numbers at all. So if I go back up here where I said when finding the GCF of coefficients, you look for the largest factor, but when finding the GCF for variables, you look for the smallest exponent. So if I'm looking here, I've got x squared and x to the 5th. So really I've got, if I were to break this down, x squared is x times x, right? And x to the 5th is x times x times x times x times x. So if I were to find GCF, I can pull one x out of each of them, and I can pull another x out of each of them. So then when I start multiplying, that's all I can take out because I'm out of red x's. X times x, well, there's an exponent of 1, is really x squared. So if you notice, that's the same thing as that smallest exponent. So that's how you're going to find when you have variables and exponents. You're going to look for the smallest one, and that's always, always, always going to be your GCF for that one, because that's the biggest thing I can take out of both of them, would be the smallest one. So like if I look at number 6, now I'm going to mix it up. We're going to put numbers, and we're going to put variables into it. So like 3x is literally just 3 times x. 24, we got to break down 24 a little bit. So maybe 2 and 12, 3 and 4, and then 2 and 2. So if I were to write that one out, I would have 2 times 2 times 2 times 3. And then I also have 2 x's I'm multiplying by. So when I go to pull out, I've got 3, 3. So I can take out 1 3 out of both of them. X, x. I can take 1 x out of both of them. So 3 times x is just 3x. That would be the greatest common factor. Again, numbers, you know how to do the number part. The x's I'm looking at, I've got an x to the power of 1 and x to the power of 2. So x to the power of 1 would be the biggest thing I could take out of. So I already knew what the variable in exponent would be. So let's look at this one. So let's just break down the numbers, 12 and 18. I'm pretty sure we did this one up here. No, 12 and 16. Just kidding. So this would be 3 and 4. The 4 can then break down to 2 and 2. And so I'm done there. Those are all prime. Then I've got 18, which let's do 3 and 6 maybe. And then 6 breaks down to 2 and 3. So then, if I'm finding the GCF with the numbers, I can take a 2 out of each of them, and I could take a 3 out of each of them, which gives me 6. Then with doing the x's, their variables, I'm going to take the smallest one. So out of my variables, I've got an x to the third and an x squared. X squared is the smallest, so I'm going to pick x squared. That's the biggest one I can take out of both of them. Because I can take x squared out of x to the third, and I can take x squared out of x squared. So my answer is 6x squared. Okay, this next one, it looks like it says 8.5, but it's really number 8. And then the coefficient there is 5. So 5, again, is prime, so I'm done with all of that. I just have to break down 20, which is 4 times 5, which can be broken down. So in this case, our biggest number would be 5 that I could take out of both of them, right? 5 and 5. So 5 is the GCF. Then I'm looking for my x's. I've got x to the third and x squared. So x squared would be the biggest x and exponent I could take out. Then I've got y squared and y cubed. Again, y squared is the smallest one, so it's the biggest thing I could take out of both of them. And then I have a z over here, but I don't have one over there, so I can't take it out. It has to be shared between the two. So 5x squared, y squared is the biggest thing I can take out of both of those monomials. So remember distributing. Let's think back to our last unit and solving equations and things. If I've got a monomial on the outside and it times a trinomial, all you're going to do is take this 3x and multiply by everything in the inside. So I've got 3x times 5x squared. So 3 times 5 is 15. I keep x, and this really has an exponent of 1. 1 plus 2 is 3. Plus I have 3 times 4 is 12. Keep x. 1 plus 1 is 2, so x squared. And then 3x times negative 1 is going to be negative 3x. So remember doing all of that? Well, now we're going to do the opposite. So when we find the greatest common factor, we're really backwards distributing. So instead of giving you the trinomial and the monomial, I'm going to give you this big polynomial, and I'm going to ask you to go backwards and give me what the two pieces were. That's what we're doing. So we're undistributing. So this is how the problems work. This is what our answers are going to look like. So you're going to have these parentheses. You're going to have all this stuff on the inside, and you're going to have some stuff on the outside. The stuff on the outside is your GCF. So just like we were finding on the front page. Where'd it go? Front page. So like this was the GCF. This was what would go on the outside of those parentheses. The stuff on the inside is going to be all your leftover pieces. So anything that's left over goes in that parentheses to distribute. So let's look at number 9. I can take a 3 out of both of these, because if I were to break down 6, I would have 2 times 3. So I can take a 3 out of both. So 3 is the biggest number, and then I look for the smallest exponent and variable, which is x. So I can take an x out. Now, if I were to take a 3x out of 6x squared, well, right now I said it was 2 times 3 times x, and then the other one was just 3 times x, right? And I took out the 3 and an x here. So I'm left with a 2 and an x. So that's going to go on the inside. Plus, I have, well, I already took out the 3 and the x, so there's nothing there. So if there's nothing there, you're going to put a 1 there to hold the place. And if we were to check ourselves, so this is our answer here, we backwards distributed. If we were to check ourselves, I'd multiply everything on the inside by everything on the outside. 3x times 2x is 6x squared. 3x times 1 is 3x. So again, we got what we started with. So again, 3x is GCF. These are our leftover pieces. Let's try another one. So if I look at 10, in this case, our greatest common factor is going to be 4, because if I take this down, I've got 5 and 4, and 4 can be broken down to 2 and 2, and this can be broken down into 2 and 2. I guess I'll do a different color. 2 and 2. So over here I've got 2 times y 4 times. And then over here in blue, I've got 5 times 2 times y 3 times. So when I'm finding GCF, I'm going to pull out a 2 and a 2, a 2 and a 2. So I've got 2 times 2, which gives me 4. Then I can also pull out 1 y from each, 2 y's from each, 3 y's from each. And again, I'm looking for the smallest exponent, which was y to the third. So that's where I got that from. So the outside pieces is the 4y to the third power. The inside's what's left. Well, over here, I just have a y hanging out. So y is left over here. Minus, there's a minus sign in between this time. Minus the blue leftover pieces, which the only thing left over in blue is 5 hanging out over here. So this would be my answer. And again, if we were to distribute to check, 4y times y to, or 4y cubed times y is 4y to the fourth, and 4y cubed times negative 5 is negative 20, y to the third, which again is what we started with. Okay, number 11. 18, let's do 6 and 3, 2 and 3. Going kind of fast on these numbers, so if you're still having trouble, go back and watch yesterday's video. This is exactly what we did yesterday with the numbers. Okay, so then the first one can be broken up into 2 times 3 times 3 times u times u times u times u. And then the blue one can be broken up into 2 times 3 times u. So then again, I'm going to break up and find the stuff I can pull out, which is 2 and 2. So 2 and a 3 and a 3. So 2 times 3 gives me 6. So there's my number. I can't pull out the other 3, so I can only pull out this one u. So that's my GCF. Then I've got to find these leftover pieces here. So the red leftover pieces, I've got a 3 and then 3u. So it's 3u to the third power. There's a minus sign, so it's minus. And there's nothing there. Remember, when there's nothing there, I just put a 1. I took everything out, so I'm going to put a 1 there. So this would be my final answer here. And again, if we went to check, 6u times u to the third, 3u to the third is 18u to the fourth. And 6u times negative 1 is negative 6u, which again is what I started with. Okay, so number 12. Now I've got a trinomial, so it's no longer a binomial. We can do the same thing. We just have 3 pieces instead of 2 pieces to look at. So I'm going to have to do 16 factored out. So really this is 2 times 2 times 2 times 2 times 3x's. Then I've got this middle piece, which 3 times 4. So the middle piece is really 3 times 2 times 2, and then I've got 2 x's. And then this last piece is 24. Which is 3 times 2 times 2 times 2 times 1x. So now I've got to pull out of all 3 colors, the red, the blue, and the purple, in order to make my GCF. So I know I can pull out a 2 from each of them. So there's 1, 2. Times I know I can pull out another 2. And then I'm done because these have other 2's, but the blue only has a 3 left. And I can't pull out a 3 because only the purple has a 3 and the red does not. So I know I'm done. So my GCF number is 4. Then I'm looking for the x's, so I can pull out 1x out of each of them. And that's it, because this guy only has 1x. And again, that's the highest x, or the lowest exponent would be just 1x. So that's how I already knew that one. So 4x is the GCF. Now I'm putting the leftover pieces in. So over here I've got 2 times 2 is 4. And then I've got 2 x's, so x squared. Then I'm doing the blue pieces, so 3 plus, because there was a plus sign here, plus 3, and then 1x. And then the purple pieces. This time it's a minus, because it was a minus sign here. Minus 3 times 2 is 6. And then I'm done. There it is, and again, we're just undistributing. Same thing with 13. So 13, I can do all the factor trees, but I know 7's my biggest number, or my smallest number, and 7 can be evenly divided into 21 and 14. So 3 times 7 gives me 21, and 2 times 7 gives me 14. So I know 7's my GCF automatically. So I'm going to take 7 out. Then I'm looking for the smallest exponent with x, which is just x, so that's the biggest thing I can take out. And same thing with y, which is just y over here, so that's the biggest thing I can take out. Then I do my leftover pieces. I took 1x out, but I still have x to the 4th over here, so I really have to put the x to the 3rd. I have y to the 3rd here, but I already have 1y out here, so I just need to put, so I just need to put y squared. Minus, we already said 7 times what gives me 21? 3. I have x squared, but I already have an x out there, so I really only need to put 1x. Same thing here, I have y squared, but I have a y out here, so I really only need to put 1y. And then 7 times 2 gives me 14, so I'm going to put a 2. And then I don't need to put x or y because the x and the y are both out here, so I don't need to list those there. So there it is. And if we were to distribute that 7xy out, we would get what we started with. And there it is. So whatever method works best, if you need to do the factor trees and list everything out like we did here, that's great. You can do that. If you can kind of look at it like we did with this one and kind of look for your least exponents and variables to see what you can pull out, you could do that as well. It's really up to you, whatever method works best for you. But that's the GCF of monomials.